Okay, this is AP Calculus, section 3.8, page 5. Just a couple of applications to the inverse trig derivatives. And we're going to start right here with find the equation for the tangent to the graph of y equals inverse tangent of x squared at x equals 1. So let's come off to the side and write down the setup for our tangent line. Y minus something equals slope times x minus, and in this case I gave you the 1, so we have the x value. Right here again is y of 1. So let's go find that y value. Y that y value okay, now, there we go. That y value is y evaluated at 1. So this should be inverse tangent of 1 squared, which is inverse tangent of 1, which is asking you where on the unit circle is tangent equal to 1. Where on the unit circle is tangent equal to 1? It's equal to 1 right here at pi over 4, and also down here at 5 pi over 4. Can you remember the restrictions on that inverse tangent? Can't give an answer in the third quadrant, only first and fourth. So inverse tangent of 1 is just pi over 4. There's your y value, right there, pi over 4. Now let's find the slope, and that slope is the derivative. So dy dx, we need the derivative of this inverse tangent of x squared. It's 1 over 1 plus the u squared, so 1 plus x squared squared times the derivative of the inside, so times the 2x. Cleaning this up, this is 2x over 1 plus x to the 4th. Now evaluate that dy dx at x equals 1. We have 2 times a 1 over 1 plus 1 to the 4th. 2 over 2 is 1. And there's your slope, right there. This is y prime at 1. All right? Let's look at this next one. Find an equation of the normal line. Normal line to f of x is arctangent of 2x over 1 minus x squared when x is 2. All right, remember arctangent? That's other notation for inverse tangent. All right, let's come down to the side and let's write down where are we going to do our normal line. Y minus something equals slope times x minus, oh, and I told you 2. Oops, can't see it. Sorry about that. All right, right here still is the y value. So this, and well, it's f of x, so I'm going to say f of 2. So let's go find that y value, f of 2. And that is arctan of 2 times 2 over 1 minus 2 squared. It's arctangent of 4 over negative 3. You're going to have to do this on your calculator because that's not a nice value that you have memorized for the inverse tangent. So we're just going to have to go inverse tangent. I have an older calculator here, so I have to put the parentheses in. Yours should come up automatically. 4 divided by -3. This one also doesn't do fractions, so I have to put divided by. You guys will probably want to use the fraction button. And we get -0.927. There's that y value. So I'm going to take that right down here, and that's going to make this become plus 0.927. And here, we just need to find f prime at 2. So let's find the slope. I'm going to box this off. I know I'm going to need space. All right, the slope. So f of x. Oh, I didn't need to rewrite anything. It'll actually be harder to not do a quotient rule here, to do this product rule, chain rule combination. It's actually easier to do this as this inside as a quotient rule. So f prime, first off, we're going to start on the outside. And the derivative of an inverse tangent is 1 over 1 plus the u squared. That's that mess. 2x over 1 minus x squared. That whole thing squared. Times the derivative of the inside. So now we have to do a quotient rule here. These big square brackets to make sure I hit all of the quotient rule. Bottom, 1 minus x squared times the derivative of the top, the 2x. Bottom, derivative of the top minus top. Bottom times the derivative of the top. It's not 2x. What's the derivative of the top? Yes, silly Mrs. Rachel, it's just 2. Bottom, derivative of the top minus top, 2x, times the derivative of the bottom, -2x, all over the bottom squared. Oh boy. All right, let's clean this up a bit. This is 1 over 1 plus, I'm going to square this out. It's going to be a 4x squared over 1 minus x squared squared. Okay? Times, inside the square brackets, if I distribute this 2 through, it's going to be a 2 minus 2x squared plus 4x squared over a 1 minus x squared squared. All right. Now let's multiply these two fractions together. The numerators are easy. That's 1 times that. That's just 2 minus 2x squared plus 4x squared. Denominator, a little bit rougher. You're going to have to take this 1 minus x squared squared over here and distribute it through to both pieces of this denominator. So first off, to this 1, it's a 1 minus x squared squared plus, when you take this piece, times that piece here, the denominators cancel, and we get a 4x squared. Okay? At this point, 1, I'm out of space, so I'm coming up here, and I could go through and simplify more, but ultimately we have to evaluate at x equals 2. So we might as well plug that in right now. F prime at 2, that's 2 minus 2 times 2 squared plus 4 times 2 squared all over 1 minus 2 squared squared plus a 4 times a 2 squared. Oh my. Lots of 2's in there, be careful. Let's see, this is going to be 2 minus, this is 8 plus 16, all over down here. This is 1 minus 4, so negative 3 squared, 9 plus 16. All right. 2 minus 8 is negative 6 plus 16, 10 over 9 plus 16, 25, which is 2/5. There's your slope. 2/5. No, that's the slope of the tangent. We want the slope of the normal, so we don't put a 2/5 here. We put negative 5 over 2. Opposite reciprocal. And down here, some of you noticed this error before. I just saw it now. I don't want to put f prime of 2 there. I want the opposite reciprocal of f prime of 2. So I have the normal line. Thanks for tuning in. I think your last day, that was your last day of notes for section 3.8. Yep, because there's page 6, left blank. Thanks for tuning in.